Now, after you're very familiar with differentiation, I need to introduce the application of differentiation. Okay. The application of differentiation dy on dx. Okay. Okay. The first application of differentiation you have to know is about tangent and normal. Okay. Okay. For example, if I have a graph and a function, okay, I use y equals to x squared as an example. Okay. Looks like that. Okay. And x is belongs to R for domain. Okay. What's happened is, um, say, okay, say someone asked me to find uh, the the tangent, the tangent and the normal at point at x equals to 1 on this graph. Okay, so the first step is we need to find the point, the coordinate when x equals to 1. So when x equals to 1, y will be 1 from the equation. The coordinate is 1 and 1. Okay. The tangent is basically referred to a straight line. Tangent and normal, they are straight lines. Okay. They are straight line. So tangent is basically a straight line has the same gradient as the graph, as the point on this graph. Okay, the tangent at x equals to 1 means the tangent has the tangent line has the same gradient as the point, say the point P. Okay, which is 1 1, and also the tangent touches, okay, tangent just touches the point B. Okay, the tangent, okay, only touches the point B. Okay, this is basically tangent. Okay. In other words, well, the physical meaning of the tangent is, I can say it is the slope of the graph at x equals to 1. Okay. Also, in the normal is another, okay, the normal is the other straight line that it makes a right angle to the tangent. Okay, we call it the normal. Okay, in math method, you have to, okay, you have to be able to find the equation of the line tangent and the equation of the line normal. Okay, so let me just write down the definition here. Okay. Tangent is a straight line that has the same gradient. Okay, the tangent of a point is a straight line that has the same gradient as the point, and also touches the point. Okay, say the point P. Okay, normal. Okay, well, normal also touches. Okay, normal is the line. Also touches the point P, and make a right angle with the tangent. Okay, the tangent. Okay, this is the definition of the tangent and the normal. Okay, okay, let me do these problems in. Okay, show you. So, okay, let's look at the graph. Okay, the coordinate is 1, 1, and we need to find the tangent first. Okay, so we know the tangent has the same gradient as the graph at point 1 and 1, so we need to find the gradient of the point, the coordinate P, the gradient of the point P on the of the graph, so we know the gradient of the tangent. Okay. So yeah, the straight line. So y equals to x squared. X belongs to R. Okay, and dy dx is equals to 2x. Okay. The domain doesn't change. X belongs to R. Okay, and when x equals to 1, okay, the gradient dy dx is going to be 2. Okay, so our tangent, okay, is a straight line. We know a straight line has a formula y equals to mx plus c. M is the gradient and c is a constant. So I know, okay, the gradient is 2 because we found the gradient there already. Okay, so the tangent will be y equals to mx plus c, and now I have to find the point c. Okay, also let's look at the definition of the tangent. The tangent well has the same gradient, but also touches the point P, and the point P is when x is 1, y is 1. We substitute it from to the equation. We have y coordinate, which is 1. So okay, this straight line has to go through the point 1 and 1. Okay, so when x equals to 1, y will be 1. Let's substitute this condition to the tangent line. So 1, okay, y is 1, so x is 1, x will be 2 times 1 plus c, and 1 equals to 2 plus c. C is going to be minus 1. Okay, now we know the value of c. So the tangent of the graph y equals to x squared, x belongs to R, at x equals to 1 is y equals to 2x minus 1. Okay, we find C here, okay, and we find our tangent. Now what do is we have to find normal. Okay, we find the line normal from the property of the normal is normal goes to the point 1 and 1 2, and also make a right angle with the tangent. Okay, here is something you have to remember. Okay, when two lines make a right angle with each other, their gradient, okay, say the product of their gradient will equals to -1. Okay, so when two lines, okay, is perpendicular, okay, perpendicular, I think that's how do we spell it. When two lines are perpendicular to each other, okay, their gradient, the product of their gradient, the product of their gradients is -1. What does this mean is the gradient of the tangent, okay, times the gradient of the normal will be equals to -1. Okay, so now I substitute, we can use this equation. Okay, the gradient of the tangent times the gradient of normal, okay, equals to -1. The gradient of tangent is 2, okay, times the gradient of normal equals to -1. So the gradient of normal will equals to -1 on 2. Okay, and as a result, I will have my line of normal. My line of normal will be y equals to mx plus c. This is the general equation for straight line. Okay, and this now I know the gradient of the normal, which is -12. So I would have y equals to -12 x plus c. Okay, again we need to find the value of c, and also, okay, we know normal is the line touches the point P. Okay, normal also touches the point P here. So point P is 1 and 1. So I substitute this coordinate in. So when x equals to 1, y will be 1, and 1 will be -12 times 1 plus c, and c will be positive 3 on 2. Okay, so my line of normal is y equals to -12 times x plus 3 on 2. Okay, this is my normal, the equation of the line normal there. Okay, now we solved the question.